Okay, get this. We're diving into a future with robots
Huh.
roaming asteroids, fuel made from space ice,
Wow.
and AI mapping out the most efficient cosmic mining routes.
Sounds pretty futuristic.
It does, right?
Yeah.
But it's the reality
Yeah.
these student capstone projects are tackling in the field of asteroid mining.
That's right.
I can't wait to unpack all this.
It's really quite amazing how these projects take years of academic study
Yeah.
and turn them into real-world solutions for space exploration.
Yeah.
It's really like a bridge between textbooks and the cosmos,
Uh-huh.
and the results are truly remarkable.
So tell me, what are the biggest problems these students are trying to solve?
Well, you have to imagine the challenges of mining an asteroid, right?
Yeah.
You've got the harsh environment of space, the unpredictable terrain of these celestial bodies, and then the need to operate autonomously, millions of miles away from Earth.
Yeah.
So these capstone projects are addressing these issues head-on
Okay.
by focusing on designing robots that can navigate asteroids,
Yeah.
developing systems to create fuel from resources found in space, and using AI to plan the most efficient mining missions.
Hold on. Creating fuel from resources found in space.
Mm.
That sounds insane.
It does.
Break that down for me. What does that even look like?
So that's what we call in situ resource utilization, or ISRU for short.
ISRU. Okay.
So essentially, it's about using what's already available in space to support space exploration. One really exciting example is using water ice,
Okay.
which is believed to be abundant on certain asteroids. And these projects are looking at ways to convert that ice into usable rocket fuel.
So instead of hauling fuel all the way from Earth, we could be creating it
That's right.
in space. That's a game changer.
It is.
What about these robots? What kind of tech are we talking about?
We're talking cutting-edge robotics combined with artificial intelligence.
Mhm.
One project, for example, focuses on autonomous robotic miner design. And these students are developing robots that are capable of navigating the treacherous, unpredictable terrain of an asteroid, identifying and extracting valuable resources, all on their own.
Okay, now I'm really picturing this. Robots crawling on asteroids,
Uh-huh.
scooping up precious materials. But how do they know where to go? How do they even find these valuable resources?
That's where the AI comes in.
Okay.
These robots
Yep.
are equipped with sophisticated sensors and algorithms, allowing them to analyze the asteroid's composition and pinpoint the most resource-rich areas.
Wow.
It's like giving them a treasure map and a super-powered metal detector.
Well, that's wild. I mean, are we talking the prototypes they're building, or is this purely theoretical?
Many of these projects actually involve creating real functioning prototypes.
Wow.
For example, in the Autonomous Resource Prospector project, students developed a prototype robot with AI-driven navigation and resource mapping capabilities, and it successfully demonstrated the potential of autonomous resource identification and extraction on a simulated asteroid surface.
A real working prototype. That's incredible.
It is.
And I'm curious, about this whole fuel from space ice thing, did any of the projects actually manage to create fuel?
Absolutely. The ISRU-based Propellant Production System project successfully simulated the conversion of water ice into usable rocket fuel. They focused on producing liquid hydrogen and oxygen,
Great.
the most common components of rocket propellant. Imagine the possibilities.
Yeah.
Refueling spacecraft in space, extending mission capabilities, and reducing our reliance on Earth-based resources.
That's amazing. It feels like we're taking a giant leap towards making space exploration more sustainable and accessible.
I agree.
So we've got robots mining asteroids, fuel being made from space ice. What other mind-blowing innovations are these students coming up with?
Well, one project that really impressed me focused on optimizing the planning of asteroid mining missions.
Yeah, okay.
It's all about maximizing efficiency
Okay.
and minimizing costs,
Right.
which is crucial when you're operating in the vastness of space.
So we're talking about AI plotting the most efficient routes and strategies.
exactly.
Kind of like a space-age logistics
Yep.
operation.
Exactly. This project developed algorithms
Mhm.
that optimized trajectories for multiple asteroid mining missions. And the results were really impressive.
Oh, okay.
A 30% reduction in fuel consumption.
Wow, 30%. That's huge.
It is.
Imagine the impact that could have on the cost and feasibility of these missions.
Yeah,
That
yeah.
kind of efficiency could really open doors for future exploration and resource utilization.
Absolutely. And it really highlights the crucial role
Hmm.
that AI and advanced algorithms are going to play in the future of asteroid mining.
It's incredible to think that these students are already developing solutions for real-world challenges
I know.
that we'll be facing in space exploration. It's like they're laying the groundwork for a future where humanity becomes a multiplanetary species.
It is inspiring to see. These capstone projects are not just theoretical exercises. They're really pushing the boundaries of what's possible and giving these students incredible experience that will be invaluable as they move into careers in this burgeoning field.
You mentioned that these projects are bridging the gap between academia and real-world application. What's that process like? How do these ideas make their way from the classroom to, well, the cosmos?
Well, it's a multifaceted process that involves rigorous testing, evaluation, and showcasing of these projects. Often they undergo a peer review process, which is crucial for ensuring quality and identifying areas for improvement.
So it's not just about grades. It sounds more like a collaborative process where students learn from each other and refine their work.
Exactly. Peer review is about fostering collaboration, ensuring the quality and impact of the project, and identifying potential improvements. It's a chance for students to learn from each other, challenge assumptions, and refine their work through constructive feedback.
And how does that feedback work? Is it like a formal review process or more informal discussions?
Well, it can vary depending on the project and the academic institution, but it often involves both written and oral reviews. Written reviews allow for a thorough and structured analysis of the project, while oral reviews provide an opportunity for real-time interaction and clarification.
It sounds like a mini thesis defense.
Yeah.
But with robots and spaceships.
That's a great analogy. And just like a thesis defense, these presentations and peer reviews are valuable learning experiences. They help students develop critical thinking skills, learn how to defend their ideas, and refine their work based on constructive feedback.
So it's about more than just technical skills.
Absolutely.
They're also developing those essential communication and collaboration skills. They're so crucial in any field. But I'm curious, how do these projects get showcased to the wider world? Are we talking presentations, demonstrations, maybe even competitions?
All of the above.
Really?
These projects are often showcased in a variety of ways, including oral presentations, poster sessions, where students visually represent their work, and even live demonstrations of their prototypes. And yes, there are competitions that provide students with opportunities to showcase their skills and connect with industry professionals.
Okay, now I'm picturing something like a science fair. But for space exploration, what kind of competitions are we talking about?
There are some really exciting ones out there. The space mining innovation competitions, for instance, encourage the development of innovative technologies for asteroid mining. These competitions not only provide recognition and potential prizes, but also offer invaluable networking opportunities and exposure to potential employers. And then you have things like ESA's concurrent engineering challenges, which focus on collaborative design and problem solving in the context of space missions.
Wow, so these students aren't just learning about asteroid mining. In a classroom, they're actively contributing to its development and potentially even shaping the future of space exploration.
Exactly, and what's fascinating is that these competitions often attract participants from various academic backgrounds. You have engineers, computer scientists, even biologists, all coming together to solve these complex interdisciplinary challenges. It's a testament to the collaborative spirit that's driving innovation in the space industry.
It's incredible to see how these capstone projects aren't just about acquiring knowledge, but also about applying that knowledge to solve real-world problems. And, in a way, pushing the boundaries of human ingenuity. But I have to ask, with such ambitious goals, surely these projects aren't without their challenges, are they?
Right, they're not.
What are some of the obstacles that these students face when tackling these projects?
Well, time is always a factor. In academic settings, these students are working within the constraints of a semester or a school year. And that can make it challenging to really develop and refine complex projects like these. Plus, you've got the limitations of resources, budgets for materials, access to specialized equipment. Those are real-world constraints. They have to navigate.
They're getting a crash course in the realities of space exploration. Even the most brilliant ideas have to contend with practical limitations.
Exactly. And beyond those logistical challenges, there's the inherent complexity of the problems they're trying to solve. Balancing creativity with feasibility is a constant dance. You know, it's great to have ambitious, out-of-the-box ideas. But those ideas need to be grounded in scientific principles and achievable within the given constraints.
That makes sense.
Yeah.
It's one thing to dream up a self-replicating robot miner, but it's another thing entirely to actually design and build one.
Exactly. And let's not forget the importance of feedback.
Oh, yeah.
These projects thrive on constructive criticism. Learning to give and receive that feedback effectively is a skill in itself.
So it's not just about taking criticism gracefully, but also about giving it in a way that's helpful and productive.
Absolutely. It's about focusing on the work, not the person, providing specific, actionable suggestions for improvement. The goal is to help each other grow as researchers and engineers, and ultimately to create the best possible project.
It sounds like these capstone projects are a microcosm of what it takes.
You hit the nail on the head.
To succeed in a real-world setting, especially in a field as demanding as space exploration.
It's about problem-solving, collaboration, communication, critical thinking. All these skills come into play. It's really impressive to see how these students rise to the occasion.
It's incredibly inspiring. And honestly, it makes me think about all those sci-fi movies I loved as a kid back then. The idea of mining asteroids and building fuel depots in space seemed like pure fantasy.
I know.
But these students are turning those fantasies into reality, step by step.
It's amazing, isn't it?
It is.
It really is a testament to the power of human ingenuity and determination. And while we may not be launching spaceships from asteroids just yet, the groundwork these students are laying is bringing that future closer.
So what's the big takeaway here? What should our listeners walk away pondering after this deep dive?
Well, I think the biggest takeaway is the sheer potential of asteroid mining and the incredible talent and dedication of the students who are pushing this field forward. Their research, their innovation, their problem-solving skills, it's all contributing to a future where humanity expands beyond Earth and taps into the resources of our solar system.
It's exciting. It's inspiring. And it makes me wonder, what kind of asteroid mining capstone project would our listener design if they had the chance?
That's a great question. What problem would they solve? What innovation would they create? The possibilities are truly out of this world.
It's been an amazing deep dive. Thanks for joining me.
It's been a pleasure.